Welcome back. So in some previous videos, we've seen that Python has some advantages for dealing with data versus using Google Sheets or another spreadsheet tool. We have a lot more control over the data and we can work more quickly once we know what we're doing. I see that Skeletor here is holding some example data in the palm of his hand, and I'd really like to get access to it. How can I combat Skeletor to achieve control of this data? Let's take a look at it. I'm opening it here with a text editor, just to see what the data looks like. It's always good to inspect data, although if you open a data file, a CSV file, on a modern Mac laptop, it might convert the data type to a numbers file. On any computer, it might try to outsmart you and convert the data type, but here I see I have a CSV file. What does that mean? Each of these columns is separated by a comma separated value. That's what this means. And then carriage return, hitting enter, marks the file with a character that means go to the next line. So I see I have 3 columns and there's a header line. The header says that my values are t, x, and y. So this probably means time and position, horizontal and vertical. Just guessing. Often we find this in physics, in science. We're given a file and we need to make some sense of it, whether it came from a satellite or from another research group or from a government website. We want to access data and process it and make meaning. That is our mission. So let's see, how can I do this? How can I get access to this file? Well, we're going to go back to our tool, our web-based tool that works for everyone, colab.research.google.com. I would like to make a new notebook. And now we need some tools. We need to import some modules to allow us to access this data. So the first thing I remember from last time that I want to import NumPy to access the tools for numerical structures that are useful, like arrays, as NP, so we don't have to type NumPy every time. For our plotting, I'm going to import matplotlib.pyplot .pyplot as PLT. So we'll just type PLT when we want to access that module. Now to access files from another module called google.colab. Since Google is kind enough to host this service on their servers, we need to use one of their tools to access files via our Google Drive. We're going to import a module called files. You might notice I'm not saying import, but from this thing, import files. So I don't need access to this whole module. I just want files so that I can type files and access that library. To help deal with the file type, I need to import a module called IO, which stands for input output. And we're going to use a structure called a data frame, which comes from a library called pandas. So from import pandas as PD is what we want to do. So that handles all of our imports of modules for this task. Now, to actually get the data, I guess I'll give it a logical name. I'll call it data, and say that equals files.upload. So there's a command in the files module called upload, which will allow me to grab that file from Skeletor's hand on my desktop. I'm going to hit Shift-Enter to execute this cell. It is thinking. And it gives me this little browse radio button to click on. I click on that file, go to my desktop, and I see data_example.csv. I'm going to choose that file. So we've imported the file. Now notice that I'm in a separate cell. Anything I change, if I need to get the data again, I need to run this cell again with the execute button here, run cell. So in my new cell, I want to convert the file that I read into a data frame, a structure that lets me access that data in a more convenient way. Since it's a data frame, I'll call this thing df, and from the pandas library, we're going to access pandas as PD, so we type pd.read read, and it's, notice, auto-completing here. As I start typing CSV, read CSV is the command that I want to use. And here I'm going to access the IO module. The details of how and why this works don't matter right now. Sometimes our biggest challenges are converting one data type to another, and we can always be grateful that someone else figured out how to convert those data types so that we can make use of that conversion process. I'm going to access the file that I just imported, which is called data, and in square braces here, damped, what is the data called? Data example.csv. Now I need to know what kind of character encoding this used, and the way we do that is by saying .decode. This is a UTF-8 character encoding. You don't need to know anything about how this command works or why it works. I will give it to you in the tutorial. I don't have a sting.io. I have a string.io. You'd think it would know what I meant, right? Computers just don't seem to know what you mean. That worked, but I need a new cell. Shift-Enter gives me a new cell. Now let's try df.head. This will show us the head of that data frame. Notice I have the first row here, T, X, and Y. And I can see with line numbers on the left, the columns of my data. So we've successfully imported this data into a data frame that we can access with everything we know about Python. For convenience, we use this data frame to get the CSV file. However, we're going to use some tools later that make use of just NumPy arrays. We don't need all of the pandas tools. So to keep this simple, I'm going to convert these columns into NumPy arrays. To access that, I see that the names of the files, the names of the columns in this file are T, X, and Y. So I'm going to define a variable called T, which is df.t. That's just the T column of the data file. Similarly for X and Y. Now to convert those from columns of a data frame, which is just another data structure from this library, into Python arrays that we've seen before, I'm going to say X, start with T, T equals np.array of T. And we'll do the same thing for X and Y. We'll execute this block with a Shift-Enter, which both executes the block and creates a new block or cell in this notebook. I'm curious what T looks like, so I'm going to type T just to echo its value for a second, and I see T is a Python array. It begins at 0, has a lot of values. It runs up to 6.28 and change. That looks like a familiar number to me. This seems to run from 0 to 2 pi. So I'm thinking this is a list of angles. We're making sense of this data. We don't totally know. Maybe T stands for theta, or maybe it stands for time. What is the length of T? We can type len T, see what that gives us. I see that this has a length of 501, and remember that one of those rows was the header row with the names of each column, T, X, and Y. We might guess that the first row is the header, but let's check. T of 0 will give us the first element of T, and I see that that is a 0. So we don't have the header here. We stripped the header when we converted this to a NumPy array. I'd like to see what this data look like. So to check that out, we're going to use our plotting function. Remember, plotting comes from the PLT library, which we imported up here in our first cell in the notebook. PLT is matplotlib.pyplot. plt.plot, and let's plot t, x, and make that green. Hit Shift-Enter and see how that looks. Matplotlib.pyplot has no attribute plt. Because I typed plt.plt, I'm leaving in errors like this just to show you the process. I see that this looks purely sinusoidal. So this is what x looks like as a function of t. Let's also do plt.plot t, y. And let's make this one say blue. Shift-Enter to execute it again. And on the same axes, I can see this also looks sinusoidal, but it looks like it has a different period from the first data set that we plotted versus t. I find it a little bit difficult to understand these plots when they're overlapping and interfering in this way, so can we make some subplots? Let's see how we do that. I'm going to make a figure. Figure is a command also part of PLT, so plt.figure. And let's make a subplot, plt.subplot. The syntax here is the number of subplots up and down, the number of subplots side to side, and which subplot we're looking at. So I'm going to have a stack of 2, only one plot wide though, and we're looking at the first plot, and then plt.subplot 212 will give us the second subplot. Let's execute that again and see what it looks like. So now we have stacked our plots on top of each other so that it's easier to see how they relate to each other without overlapping at the same time. So I see these have the same amplitude as each other, but a different frequency. Now often when I have t, x, and y in a file, that makes me think that maybe x and y are both functions of t, but describe some position over time. So that makes me wonder, how does x versus y look? We call that a parametric representation, when x and y both depend on a common variable called the parameter. So let's see what that looks like. We'll make a new figure, plt.figure. I'll call this figure figure 2, and plt.plot x comma y, just because we can. Let's make this one red and take a look at how that looks. I see that we have this beautiful, it's called a Lissajous figure, Lissajous, French. These kind of patterns happen in a number of systems. Details don't matter right now, but we've seen that we can plot a parametric curve of 2 variables from a data file, which we imported. We can also subplot, where we've indicated the height, how many subplots tall we're using, how many subplots wide we're using, that's the second number, and which subplot are we talking about, the first or the second. That was how we created that structure. So I hope that gives you some detail. Please follow along and recreate this process to create these plots and practice importing data and visualizing it with CoLab notebooks.